By 1940, the United States faced a strategic materials crisis that threatened to cripple its industrial mobilization. Ball bearings, essential to nearly every moving machine, were controlled by a single German cartel. America had built an alternative, but few understood what made it different. This is the industrial history of the tapered roller bearing, a technology developed outside the German monopoly that dominated global precision engineering for half a century. It is the story of how one invention, born from a carriage maker's frustration in 1898, became the foundation of American heavy machinery, military logistics, and global infrastructure. The company that manufactured it became synonymous with durability under extreme load. Its wartime role was significant, but the technology's broader legacy extends far beyond any single conflict. In the late 19th century, friction was the silent destroyer of industrial progress. Axles wore down, shafts overheated, wheels seized. The faster machines moved and the heavier their loads, the more catastrophic the failure. Ball bearings, first patented in the 1790s and refined throughout the 1800s, offered a solution by replacing sliding contact with rolling elements. By the 1890s, Swedish engineers Sven Wingquist and Germany's FAG and SKF had perfected the radial ball bearing, transforming bicycles, electric motors, and light machinery across Europe. But ball bearings had limitations. Under combined radial and axial loads, forces pushing both outward and sideways, individual balls compressed at single contact points. This concentration of stress caused deformation, heat, and premature wear. Heavy equipment such as railroad cars, industrial wagons, and agricultural machinery required something more robust. European manufacturers dominated the market, and their products were designed for precision, not punishment. In St. Louis, Missouri, a German-born carriage maker named Henry Timken encountered this problem firsthand. Timken had immigrated to the United States in the 1850s and built a successful business manufacturing carriages and wagons. But the friction generated by traditional journal bearings and even ball bearings in his carriage axles remained unsatisfactory. The wheels wore unevenly, loads shifted, lubrication failed under sustained use. Timken was convinced that a better bearing existed, one that could distribute weight across a larger contact area and handle both radial and thrust forces simultaneously. Henry Timken's solution came in 1898. Instead of spherical balls, he designed conical rollers arranged at an angle between matching inner and outer raceways. Each roller made line contact rather than point contact, distributing the load across a broader surface. The conical geometry allowed the bearing to handle both radial and axial forces in a single assembly. Timken received U.S. patent 606,635 in June 1898, marking the birth of the modern tapered roller bearing. The invention was elegant in principle but difficult to manufacture. Tapered rollers required precise grinding to ensure uniform contact along the entire length of each roller. The raceways had to be machined to exact angles. Any deviation caused uneven load distribution, accelerating wear. European ball bearing manufacturers had spent decades perfecting their tolerances. Timken had to develop equivalent precision for an entirely different geometry. In 1899, Henry Timken founded the Timken Roller Bearing Axle Company in St. Louis with his sons, Henry H. Timken and William R. Timken. Early production focused on carriage and wagon axles, where the bearing's ability to handle side loads and cornering forces provided a clear advantage. By 1901, the company relocated to Canton, Ohio, positioning itself closer to the steel mills of the Midwest and the emerging automotive manufacturing centers of Detroit and Cleveland. The relocation proved strategic. America's industrial economy was accelerating. Railroads were expanding. Automobiles were transitioning from experimental novelties to mass production. Heavy machinery for mining, agriculture, and construction was proliferating. Tapered roller bearings found applications wherever loads were heavy, speeds were moderate, and reliability was non-negotiable. By 1910, Timken bearings were standard equipment in railroad freight cars. Traditional journal bearings required frequent maintenance and caused wheel wear that led to derailments. Tapered rollers reduced friction, extended maintenance intervals, and improved safety. The Interstate Commerce Commission began recommending their adoption across American railroads. Henry Timken died in 1909, but his sons continued to expand the company's capabilities. They invested heavily in metallurgy, recognizing that bearing performance depended as much on steel quality as geometric precision. In 1917, Timken opened its own steel mill in Canton, integrating raw material production into the manufacturing process. This vertical integration gave the company control over alloy composition, heat treatment, and quality assurance, advantages that European competitors, reliant on external steel suppliers, could not easily replicate. Through the 1920s, Timken grew alongside American industry. The company supplied bearings for trucks, tractors, industrial machinery, mining equipment, and machine tools. Tapered rollers became the standard for heavy axle loads, while ball bearings remained dominant in high-speed, low-load applications such as electric motors and small appliances. The two technologies were complementary, not competitive, except in industries where both radial and thrust loads were present. The automotive industry presented a particularly demanding application. Front wheel bearings in automobiles had to support the vehicle's weight, absorb lateral forces during cornering, and accommodate braking stress. Early ball bearing designs struggled with durability. Timken's tapered rollers, designed to handle precisely this combination of forces, became standard equipment in American cars and trucks by the mid-1920s. By 1930, Timken had expanded beyond the United States. The company established manufacturing facilities in Europe, though it remained a secondary player compared to Sweden's SKF and Germany's FAG, both of which controlled the ball bearing market. Timken's strategy was differentiation, not direct competition. It focused on applications where tapered rollers offered superior performance: railroads, heavy trucks, construction equipment, and industrial gearboxes. The Great Depression slowed growth, but Timken's diversified customer base, spanning automotive, rail, mining, and agriculture, provided relative stability. By the late 1930s, as global rearmament accelerated, demand for bearings surged. Governments recognized that bearings were not merely components, but strategic materials. Without them, vehicles could not move, guns could not traverse, and machinery could not operate. By 1939, the ball bearing industry was effectively a European monopoly. Sweden's SKF and Germany's FAG and VKF controlled global production, patents, and distribution networks. The United States imported most of its precision ball bearings from Europe, particularly for aircraft engines, machine tools, and military equipment. This dependence became a strategic vulnerability when Germany invaded Poland and European supply chains collapsed. American military planners faced a critical gap. The U.S. possessed limited domestic ball bearing production capacity, and existing facilities could not scale quickly enough to meet wartime demand. Precision ball bearings required specialized machinery, trained labor, and years of manufacturing refinement. The Army and Navy needed millions of bearings for aircraft, ships, tanks, and vehicles, and needed them immediately. Timken, however, was already positioned to respond. Its tapered roller bearings, though different in design, served many of the same applications. Heavy trucks, military vehicles, tanks, and artillery systems all required bearings capable of handling severe loads under harsh conditions. Timken's vertically integrated production, from steel smelting to final assembly, allowed rapid scaling without dependence on external suppliers. Between 1940 and 1941, before the United States entered the war, Timken expanded its Canton facilities and increased production capacity. The company worked with military engineers to adapt tapered roller bearings for specific applications: tank transmissions, half-track axles, naval propulsion shafts, and heavy artillery mounts. In cases where ball bearings were essential, Timken partnered with emerging American manufacturers to transfer knowledge and increase domestic capacity. After December 1941, American industrial mobilization transformed Timken into one of the largest bearing manufacturers in the world. The company operated around the clock, producing millions of bearings for military vehicles, ships, aircraft, and machinery. Tapered rollers proved particularly effective in applications where durability mattered more than absolute precision: truck axles, tank transmissions, landing gear struts, and ship propeller shafts. One of Timken's most critical contributions was in military logistics vehicles. The U.S. Army's fleet of trucks, including the ubiquitous GMC CCKW and the Studebaker US-6, relied on Timken bearings in their front and rear axles. These trucks formed the backbone of Allied supply chains, moving ammunition, fuel, food, and equipment across Europe, North Africa, and the Pacific. Bearing failure in a logistics vehicle could strand an entire convoy, making reliability a matter of operational success. Tanks presented a more demanding challenge. The M4 Sherman, The primary American medium tank used tapered roller bearings in its final drive assemblies, suspension bogies, and transmission. The Sherman's reputation for mechanical reliability, often contrasted with the more powerful but less dependable German Panther and Tiger tanks, owed much to the simplicity and durability of its drivetrain components, including its bearings. Germany, meanwhile, remained heavily dependent on centralized ball bearing production. The factories at Schweinfurt produced the majority of German precision bearings, making them a strategic target for Allied bombing. In 1943, the U.S. 8th Air Force conducted multiple raids on Schweinfurt, disrupting production and forcing German manufacturers to disperse operations. While German ball bearings were superior in precision applications such as aircraft engines and gyroscopes, their vulnerability to supply chain disruption became a strategic weakness. Timken's distributed manufacturing model, with multiple facilities and in-house steel production, proved more resilient. Even as the company scaled production to unprecedented levels, quality remained consistent. By 1945, Timken had produced over 100 million bearings for military use, supporting Allied mechanization across every theater of war. The end of the war did not diminish demand for tapered roller bearings. Post-war reconstruction, global infrastructure development, and the expansion of commercial aviation created new markets. Timken transitioned from military to civilian production, supplying bearings for railroads, trucks, agricultural machinery, and industrial equipment across Europe, Asia, and Latin America. In the 1950s and 1960s, the company expanded globally, establishing manufacturing facilities in Europe, Australia, and later Asia. Tapered roller bearings became standard in heavy-duty applications worldwide: freight railroads, mining equipment, wind turbines, and construction machinery. Timken's engineering expertise extended beyond bearings to include power transmission systems, specialty steels, and lubrication technology. The railroad industry remained a core market. By the 1970s, nearly every freight car in the United States and Europe used Timken bearings. The reduction in maintenance costs and improvement in safety made tapered rollers the industry standard. Similar adoption occurred in commercial trucking, where bearing failure could cause catastrophic accidents. Aerospace applications expanded as well. While ball bearings remained dominant in high-speed turbine engines, tapered rollers found use in landing gear, helicopter transmissions, and actuator systems. The space program relied on Timken bearings in launch equipment and ground support machinery. In the 21st century, Timken continues to operate as a global manufacturer of bearings and mechanical power transmission products. The tapered roller bearing, refined over more than a century, remains fundamentally unchanged in principle. Modern materials, coatings, and manufacturing precision have extended service life and load capacity, but the core geometry Henry Timken patented in 1898 still defines the technology. The story of the tapered roller bearing is the story of industrial problem-solving extending across generations. It is the history of a technology that emerged from practical necessity, matured through iterative engineering, and became indispensable to global infrastructure. World War II amplified demand and demonstrated the strategic importance of manufacturing independence, but the bearing's legacy extends far beyond that conflict. From railroad freight cars to wind turbines, from military tanks to mining equipment, tapered roller bearings remain essential wherever heavy loads, lateral forces, and long-term reliability converge. The Timken Company's rise from a carriage workshop to a global industrial manufacturer reflects the broader trajectory of American engineering, solving problems through innovation, scaling through manufacturing discipline, and sustaining relevance through continuous refinement. The bearing that allowed America to avoid dependence on a German monopoly became the foundation of a technology that outlasted empires, conflicts, and industrial revolutions. Subscribe for more untold industrial history.